All right, so for number 2, our variables are number of brochures for X, number of flyers for Y. Got that marked. Now we start looking for the phrases, either profit cost or constraints. It doesn't matter. I think it's going to be easier if you look for cost. So let's do that first. Let's get that information out of the paragraph. It costs 8 cents to print a brochure. It costs 4 cents to print a flyer. So that whole sentence, 8 cents, so 0.08 per, which one was that again? Per brochure, and 4 cents per flyer. All right, now I'm going back to the problem, marking that sentence out so we don't have to read it anymore. We've used it. All right, now look for other phrases that limit the number of brochures and flyers that you can make. At least 50 brochures. There's one. At least 50 brochures. All right, going to the table. At least 50 brochures. Got it. I think there was another at least phrase. At least 150 flyers. That's a separate phrase. At least 150. Whoa, wrong. At least 150 flyers. And if memory serves me, there's only one more. There it is. No more than 600 pages. Now here's what's tricky. Some people read the sentence above it that says a brochure requires 3 pages and a flyer requires 2 pages and think that those are phrases that limit. But that's information that's going to apply towards the 600 pages that you just said. So it's kind of hard to distinguish between the two, but the phrase no more than 600, clearly a limit, right? No more than 600. The 3 pages and 2 pages are information that we're going to use about the 600. All right, so no more than 600 pages. All right, I'm going to go back and cross out what we've used. Got it. Got it. Don't even need the first sentence. It does set up, what's going on, but there's really only one thing left, 3 pages and 2 pages. All right, so let's just start writing our inequalities and see where we end up using that. Concrete example. Pick a number of brochures and a number of flyers that's not already in the problem, that'd be nice and easy to work with, like 100, 100, and 200. Does not matter where you put them, okay? I'm going to put the 200 right here with brochures and 100 right here with flyers. And one at a time, we're going to look at every phrase we just talked about. Starting with money. Let's knock it out. Started there earlier, so start there now. How much money does it cost to make 200 brochures and 100 flyers? I don't really want the answer to that question. I really want to know what are you going to do with the 200 in your calculator. You're going to take that 200 and times it by 0.08. You're going to take that 100 and times it by 0.04. And what are you going to do with your 2 answers? Add them. So your function is 0.08 times x plus 0.04 times y. The more practice you get at doing this, the less you're going to need the concrete example. Some of you probably didn't need it right then. You just knew what to do, okay? All right, now for the at least 50 brochures. 200, our example, at least 50 brochures. Are we good there? Of course, yes, we're good. But the important part, what did you do? You took the 200 and you compared it in your mind to see if it was bigger than 50. You agree? Isn't that what your mind did to say, yes, 200 is bigger than 50? Well, 200 is x. So x has to be greater than or equal to 50. That one feels right. if X is brochures, it has to be bigger than 50. So the next one, I think we can do it without a concrete example. Brochures have to be at least, flyers, you have to have at least 150 flyers. If Y represents the number of flyers, it has to be greater than or equal to 150. Y has to be greater than or equal to 150. If we did do the concrete example, it would just say, is 100 bigger or equal to 150? We would have said no, but it doesn't matter. The 100 represents Y, and we have gotten our inequality that way. Y is bigger than or equal to 150. It's the last one that's kind of tricky. It's the last one that we're going to have to go back and read the problem again. Do we have enough pages, 600 pages, to make 200 brochures and 100 flyers? The reason we have to go back to the problem is I need to know how many pages does a brochure take. So I'm going back to the problem, and it says a brochure takes 3 pages, which means if I'm going to make 200 of them, if I'm going to make 200 brochures, I'm going to take 200 and triple it, because it's going to take 3 pages for every brochure. But I'm also making flyers, right? 100 of them. And for every flyer I make, how many pages does it use? 2 pages. So the 100 flyers times 2, if I take those 2 different pages, let's see, 3 times 200, 100 pages, and 2 times 100, 200, and I add them up, they have to be less than or have to be smaller than the 600 I've got available. If I add them up and see if they're smaller than 600, I'm going to say no, that's not, I don't have enough pages to do that. But the important part is this. Wherever you put a 200, that's X. Wherever you put a 100, that's Y. So replace them. And your inequality is 3 times the number of brochures, 3X, plus 2 times the number of flyers, 2Y, has to be less than or equal to the 600 pages you have available. And then, real quick, logicals. Do I need to tell me X is bigger than 100? Or do I already have something on the list that's telling me X is bigger than, do I need something that tells me X is bigger than 0? Or do I already have something on the list that says bigger than 0? Yeah, we already have it in the first inequality, X is bigger than 50. Do I need a Y is bigger than 0? No, it's already covered in the second one. So the logicals aren't required here. Graph these 3 on a graph, see where they cross, find the feasible region, and then use the function that we wrote over here to minimize cost. All right, I'm going to stop the video there. You can always check your answers in class on the answer key book at